Good afternoon, Mana. Okay. Yeah, good afternoon to everyone. Yep. Right. Previously, we completed the accelerated body, Mana, uniformly accelerated. Okay, I think in that we did few different models related to uniformly accelerated body. Okay. Then here, sometimes they compare two motions, Mana. Two motions means if you come to this example here today, you take, like suppose here, as usual, it is a straight line motion. Okay. In that straight line motion, from starting from A, here, this is the model comparing with the motions of two bodies. Okay. One person started from A, say person P. Okay. Another person simultaneously started from the same point. He is Q. Right? And how is the motion of P and Q? If you ask me, he is saying here in that question, giving more clarity. P started from A with a constant velocity of 4 meters per second. Okay. Suppose he is driving his car. He starts with some constant velocity and drives in this direction along this line. Okay. With 4 meters per second. But Q, how is his motion? If you ask me, he is saying that he is started from here started from rest. Okay. And started from rest means you can say that his initial velocity is 0. Okay. And Mr. Amok, are you there? Why you joined too late today? It's around 3, 4. Even very smart. In the previous class also you joined at 3, 5. Did you remember? Means on Mondays, in Monday's class. On Monday also you joined at 3, 5 around. Class is at 3 o'clock, not at 3, 5. Right? Okay, Aicha MS, you also joined late today. Okay, no problem. Right here, started from rest. Okay. Right, started from rest and accelerated okay with some acceleration and he gave accelerated with the constant maybe nana. Okay, right. Even you also joined very late in the previous class, that's why I asked particularly you both. Okay, right, no problem. Accelerated with some constant acceleration. Constant acceleration here. Lakshmi Gayatri, why she joined late? Good afternoon, Lakshmi Gayatri. You joined around at 3:06. May I know the reason? Okay. Right. Afan Ahmad, good afternoon. Every day you are joining too late, Nana. What I observed. Good afternoon. But every day you are joining around at 3:05 or 3:10. I don't know what is the reason behind. Okay. Right. Okay, Nana. Okay. Oh, you joined in the second device now. Lunch at 3 o'clock. Okay, right. Good. I think it is not Friday. Today is not Friday. It is Afan Ahmad. Today it is Wednesday, not Friday. Okay. Right. With a constant acceleration of say some 2 meters per second square. Okay, no problem. 2 meter per. The reason behind is I start obviously at 3 o'clock, Nana. If you join in the middle, I think obviously you miss something. Whatever the initial data I give here, then you may get some confusion. Okay, you are going to join in the middle again, you may get some confusion and ask, sir, what happened, sir? What happened, sir? Will you please repeat, sir? Okay, it will be a sort of disturbance to others. Okay, that you have to understand, not you all who are going to join after 3 o'clock. Okay, na? Right, it's not an issue. Leave it. And then come here to the problem. Started from rest. That's what I'm saying. All of you joining around at 3:05 or 3:08 and asking that, sir, once you please explain the part what you explained, sir. A little bit some disturbance and we can say it is one kind of nuisance also. Okay, just I started one problem on here. Two particles started from the same point A. One is started with uniform velocity, other started from rest and accelerates uniformly. Two motions he is comparing here. Uniform velocity, okay, good, and with uniform acceleration. Okay, both started from the same point, right? The question is here, when and where they come to, okay, or else simply they meet. This is the best word to use. Simply, when and where they meet. Okay. This is the question now. So here you have to understand that A is started from this point A, P. P is started from the point A and he is going with uniform velocity. Okay, uniform velocity of 4 meters per second. This is of P. Okay. Whereas Q, he is Q. Here I am taking. Q again started from here and from the same point, but started with the initial velocity of 0 and acceleration of 2 meters per second square. Okay, he started his motion from the same position, both. Okay, the question is, after starting, suppose it is slowly moving with some constant velocity and it is slowly accelerated and tries to meet the car here, car of P here at this point now. Means here the question is where they meet. To find out, they meet at one point here at the same location. Okay, where they meet after traveling a distance of s is equals to x. First, did you understand this point, Nana? What I explained here with the blue and red color? Understood. Okay, good. Means x is the distance traveled by whom? Very good. P and Q, both P and Q now. Why? Because same distance traveled by P as well as Q. Okay. So that displacement, try to write for P as well as Q. Okay, and Q, right? P and Q. So here I am going to write what is the displacement of P, what is the displacement of Q. Okay, keep in mind P is moving with the constant velocity, Nana. Constant velocity means the formula is V is equals to displacement by time. That's it. It is the velocity for a body moving with the constant velocity. Okay, so V is equals to S by T means of P. Yes, correct. That implies S is equals to, can I write it as V into T by taking cross multiplication? And here that S, distance traveled by P is X. X is equals to, his velocity is 4 into 10. Any mistake in my equation, Nana, for the particle P? No, good. Now come to here. For the particle Q, it is accelerated and asking the displacement after a time t. Displacement after a time t, here you observe. Displacement for a body accelerating, uniform acceleration after certain time. I think all of you remember displacement is equals to ut plus half at square in terms of time. Okay, so s is equals to x, that is equals to ut, u0, Nana. So ut 0 half a is 2 into t square. 16 is what, Nana? Is it x? Okay, we will check it. Here of course 2 and 2 and get cancelled, no problem. So x is equals to t square. If I substitute here, where in the first equation, that is from 1 and 2, yeah, I will write x in place of x. I am going to substitute here 4t. 4t is equals to t square. Am I right, Nana? 4t is equals to t square. Yeah, that implies t is equals to 4. Yes. So here t is equals to 4 seconds means when they meet, after how much time they meet. First question is over. Yeah, x may be 16. Yeah, I have to calculate that one. Where they meet. Where means x. So from equation 1, I think we will get very easily. From equation 1. Yeah, I think you are right. 16. Even Afan Ahmad also. Yes, from equation 1, x is equals to, yes, Nana. I think 16 only. 4 into t is 4, that is equals to 16 meters. Okay, so they meet after a time of 4 seconds at a distance of 16 meters, here traveling a distance of 16 meters from the initial point. Okay, is it clear? Or any doubt here, Nana? No. Okay, right. Good. Then come to here one more example. Okay. Suppose, means today what we are focusing more, comparing the motions of two bodies. Okay. Till yesterday we solved the motion of only the problems related to the motion of a single body. Now, in the place of velocity, I have taken time, sir. Where here, where Nana? So I got 4. Okay, okay, maybe right. No problem. Okay, I'm going to example 2 here. Okay, take it as example 1. Okay. In this example, what he's saying, again, the motion in a straight line. Okay. In this motion, problem is two buses or cars or bikes, means two particles, okay, started from not same point here, like in example 1. They are started from two different positions, but at the same time. Okay, this time P is started from rest, okay, and accelerated towards Q with uniform acceleration. A is equals to here 1 meter per second square. Okay, here Q, he started from that point, okay, with some initial velocity u is equals to 2 meter per second square, okay, and his acceleration a is equals to say 2 meter per second square. Means in this problem both are accelerated now, right? Here say the total separation between the two positions okay, total separation between the two positions you take it as 120 meters. Yeah, sure. Okay, okay, no problem. Okay, okay, here, right, okay. Okay, Nana. I will change, I will change. Okay, 120 meters, right? So take here 1. This is 120 meters. Yeah, I will change. This is 2 meters per second. What you say? The question is, what after how much time? After how much time they cross each other? Okay, this is the question. I think you will get the idea for this question, Nana. This is not much hard, actually. Surely you will get some idea for this question. Okay. Suppose they are traveling in opposite direction, means at certain time he comes to this position and traveling a distance of x in a time t. Then what will be the distance traveled by q from there to here? How much is this distance? 120 minus x. Very good. If it is x, total distance is 120. So remaining distance from here to q is 120 minus x. Accepted. Both started simultaneously. So here q also takes a time t to reach the point R here. Okay, na? Then I am asking t nana. Right? So both are accelerated in certain time. I think for both we have to use displacement in terms of time, that is ut plus half it is square in this problem. Okay, I think you will get two equations here now. Okay, suppose if I write first equation for p. Okay, s is x is equals to, I write ut is 0 nana, initial velocity, ut is 0 half a is 1 into t square. That implies here x is equals to t square by 2, equation 1. What is 0.5 nana here? Second equation is for q. Okay, right here for q. Yes, that is 120 minus x. S is equals to, okay, right, no problem. 120 minus x is equals to ut 2 into t plus half a is 2 into t square. Okay, that implies here 120 minus x, I can write it as 2t plus 2 to cancel t square now. Okay, I require t, right? So I have to eliminate x. Okay, so x from 1, if I substitute, I will get, after how much time I'm asking. So I have to find out time now. So eliminate x. That implies 120 minus x is t square by 2 is equals to 2t plus t square now. Take t square by 2 the other hand, you will get one quadratic equation. 120 is equals to 2t plus t square by 2. So if I move to the second page, here you will get 120 is equals to, I think in the previous page, 2t plus t square by 2 is 3t square by 2 nana, by adding those two. So simple here, take LCM and cross multiply. So yeah, I will get this equation as by taking cross multiplication. 240 is equals to 120 into 2 now. 240 is equals to 2 2s are 4, 4t plus 3t square. Okay, so you will get one quadratic equation. That implies the quadratic equation is 3t square plus 4t. Taking to this one to the right hand side, minus 240 equals to 0. For what, Nana? Okay. Right? Charmika. Okay. Right. 3t square plus 40 minus 240 is equals to 0. This value, what is the t? You can find out using minus b plus or minus root of b square plus using that formula. Minus b is 4 plus or minus root of b square 16 minus 4a, c is minus 240 divided by 2a. 2 into a is 3 now. Okay, this calculation even you also can do. It is very simple. Plus or minus root of 60 minus of minus plus. Here 3, 4 3s are 12 into 240. Yeah, quadratic equation only now. By here 2 3s are 6. Yeah. So this is equals to my 6 is what, Nana? Here 16 plus. Okay, no problem. Right. Or else better if you take 16 from both common, Nana, that will be easy for you. Okay, if I take 16 common in both, means 4 into 4, 1 plus 16 common means 4 3s into 4 60s. Okay, divided by 6. So that advantage is I can take 16 out, Nana. 16 if I take it out, I will get 4. Root 16 is 4. Root of calculation will be easy. Then 63 is 180. 180 plus 1 is 181 by 6. Since it is already minus, you should not take minus here. You have to take plus only. So the value is t is equals to, I am getting final calculation, 4 root of 181. This is positive value, minus 4 by 6. Now you can do something here by taking 4 common, root 181 minus 1 by 6. That is equals to cancelling 2 2s are 2 3s are 2 by 3 into root of 181 minus 1. So is it clear, Nana? Or any mistake in my calculation? Is it correct? Yeah, okay, right. Yes, I think, yeah, correct. Okay, good. So nothing wrong in my calculation. Finally, I will give the previous all pages, Nana. Then there you can take the snapshot for all. Yeah. So is it over, Nana? Can I move to next one? Yes, sir, done. Okay, right. Okay. Now look at this model, Nana. Example 3. Here, this. Yeah, this is the answer, Nana. Okay. No need to calculate what is the root of 181. Okay, you can simply leave it there. Okay, right. So here, example 3, he is saying that, which one, Nana? Second means where you have doubt. From the T means, are you asking the calculation, this calculation part? This is simple, Nana. You got some one quadratic equation here, na? Till here, did you understand how you got this quadratic equation? You understood this part? Yeah. Here, just I applied the equation, known equation. In lower standards, you know one formula now. For quadratic equation, ax square plus bx plus c is equals to 0. Then its roots are x is equals to minus b plus or minus root of b square minus 4ac by 2a. In that equation, just I substituted all the values. Ax square means in place of A is, I got there 3. Okay. B is equals to, I got 4. And C here, I got minus 240. Okay. So Ax square plus Bx plus C is minus 240 equals to 0. So in that equation, all the values here, these values I substituted here and I did simple calculation. This is just calculation part. Okay, Mr. Affan. Yeah, right. Then coming to here, Nana, problem. Example 3. One particle here accelerating uniformly. Okay. And it has some velocity u at the point P. Okay. While accelerating, suppose it comes to point Q. Okay. Its velocity is v. Right. And the total distance between these two, say some s, displacement. Okay, no problem. Displacement, yes, here. Okay. And here my question is, in between these two, exactly at the midpoint, say the point R. Okay. While accelerating uniformly, okay, you know the initial velocity, you know the velocity at the point Q, you know the total displacement S, and also you know the distance between PR also. Why? Because it is the midpoint. Midpoint means PR will be how much, Nana? Exactly how much? PR value. S by 2. Yeah. Even RQ is also S by 2. Okay, half of. Why? Because it is the midpoint. Midpoint means half of the distance, total distance. So here, while accelerating uniformly, I am asking the question, find the velocity of the body at R. That you have to say in terms of R, in terms of U and V. Okay, you have to say in terms of U and V, not in terms of A. First, all of you understood the question, Anna? Yeah, good. Is the initial velocity 0? I think no. Okay, but here observe, Nana, in this problem, if you see, come to the solution part here. Okay, I am going to the solution. Between P and Q. Yeah, good, good. Then try to solve it, Nana. Okay, in the meanwhile, I also try here on the whiteboard. Between P and Q. Okay, displacement is given as S. Initial velocity I know, final velocity I know. So initial, final, and displacement are related as, according to the equation, v square minus u square is equals to 2as. Displacement is related with initial and final. Okay. So here final velocity is v only, initial velocity u only, 2, acceleration a only, displacement s only. So nothing to change in this equation. Straight away I can take it as first equation between P and Q. Okay. And P and S. Now come to between P and S. here between P and S. Okay. The displacement will be how much, Nana? P and, sorry, P and what is this point? R. Sorry, P and R. The displacement is exactly Amok said it is S by 2. Okay. You know the displacement. Acceleration same. Started from P. U same. But at R, final velocity, I don't know. Okay. That velocity at R, I don't know. So here that velocity, can I take it as some X, Nana? Okay. Right. So between P and S, I am going to substitute again the values here in the formula V square minus U square is equals to 2S. Means again I am going to use V square minus U square is equals to 2AS formula. V square, if you understand, how much you substitute here in place of V? X, very good. So X square minus U square is equals to 2, same acceleration A, and displacement, right, displacement is nothing but S by 2. Yes, very good, very good. Then take the second equation here. I am getting X square minus U square cross multiply into 2 is equals, I am not cancelling 2 and 2. Okay, why? You can understand. By taking cross multiplication, yeah, I will take here 2AS on the right hand side. Look at equation 1 and equation 2. Both the right hands are equal. 2AS and 2AS. So in place of 2AS, I am going to substitute. Okay, substitute here from 1 and 2. Yeah, good. Now you will get the answer. I think you won't get V square is equals to U square. No, I think. Check it properly, Nana. From 1 and 2, equating the two equations, I will get V square minus U square is equal to here 2 times of X square minus U square. So V square minus U square is equals to, by taking the multiplication both. Yeah, what, Mr. Manikanta, what is this? 2 into X square minus 2U square. Okay, now I think you will get the correct answer. By taking that minus U square to the left hand side, that becomes plus 2U square. Now correct, it is correct. 2U square is equals to 2X square. 2U square taken to the left hand side now. So minus U square plus 2U square. By adding these two, how much you get? V square plus U square, Nana. By adding the two is equals to 2X square. Therefore, X square is equals to, I am getting V square plus U square divided by 2. What I asked, find the final velocity, means X is equals to how much? This is the question. Therefore, X is equals to, I got the formula root over V square plus U square divided by 2. Okay, all of you understood the calculation, Nana? Very good, very good. So this one, even you can remember it as a shortcut. Okay. Yes. Right. In a problem, suppose initial velocity is given, final velocity is given. What will be the velocity at the midpoint? You can straight away calculate. So are you able to follow all the numericals, Nana? Till today, we solved many numericals actually related to this acceleration and all. Okay. Yes, yes, very good. If I give one small assignment, will you try to solve them? Sure. Yeah, okay, right. I will try. I will try to give. Okay, Nana. Right? Try to solve them. If there are any doubts, we will discuss them again. Okay, good, good. So here, right now. Now we are going to another concept, Nana. So till now what we completed, the concepts. One is finding out distance and displacement. Concept is over, already completed. I think today one student posted one small question, okay, in WhatsApp. Personally, one student posted here. Um, I am asking Lakshmi Gayatri here. This is the question for you, Nana. Only you have to say. Vectors later we will try to do few numericals now. Okay. What she asked, this is one circle. Okay. And here one particle moves from the point, say, from one point to, okay, take some coordinate axis like here, one diameter. And of course, this is another diameter. Okay. Started from this point, Nana. Started from here, A, to the point B. Okay. We will see, anyone can try, Nana, this one. Now we are not doing numericals, sir. No. We are doing numerical. Means related to this concept, whatever we covered, we did many numericals now. Okay. Then we are moving to another concept. That's what I'm saying. Okay. Not on covered concept. We try to take new concept. But this question was posted by one of your classmates. Okay. Here, A to B, moved from A to B with some constant velocity now, making some angle theta here. Okay. When it completes some angle theta, what is the ratio of distance to displacement? Distance by displacement. Anybody can solve here. Okay. But time span is just 1 minute only. It is 3:43. That you have to say in terms of theta, Nana, Aditya. Not 2 minutes, 1 minute only. See who will solve this one. A sin theta plus A cos theta. Okay, where A you took, I think. No, I think I miss. Even Manikanta also wrong. You can take the radius as R or A. That is your wish. 180 theta pi by 180 is to 1. No. Distance to displacement. Okay, it's 344. Any answers? No. This time Amog not responded. Still doing. It is a simple question, Anna. Not a big question. Lakshmi Gayatri, theta pi by 180 is to 1. Sorry. Vaitali, this is actually simple. See here. That much simple. Okay, you do. Okay, in the meanwhile, we will check. This straight line is displacement. All of you know, displacement is measured with a straight line. And arc length is the distance. Okay, arc length means if you use the sector principle from sector of AOAB, all of you know arc length AB is equals to r theta. All of you know this formula, I think. Do you know this formula, Nana? Or else, this one you know, Nana, actually. Theta into arc length, Nana. Ayyo. In your 10th class, you know actually this formula. For 360 degrees, total length of the perimeter is 2 pi r. Total length of the perimeter. Only part if you ask making an angle theta, that's what I am saying. For theta, what is the length of AB? Is theta into 2 pi r by 360. This is arc length, you know, in your 10th class. You know it. Circumference is 2 pi r. So circumference means full circle. Full circle angle is 360 degrees. So for 360 degrees, length of full circle is 2 pi r. Okay. Right. All right. I try to learn at least now on. Okay. Here now you try to learn this one, Anna. For full angle 360 degrees, length is 2 pi r. Circumference length is. Then for theta angle, not 360 degrees, for theta angle, what will be the length on the circumference? Okay, for theta angle, how much? Cross multiplication method. Length will be theta into 2 pi r by 360. Okay, at least now you understood this formula? Okay, right. Then here look at 2 pi is nothing but 360. 2 pi radians is 360. So 360 cancel. Okay, so L is equals to how much you are getting there? There r theta only. Once I can explain. What Tali Charmi Priya? Theta by 360 is what, Nana? What I said, Charmi Priya, this is for full length of the circle 2 pi r. What is the angle made at the center? 360 degrees or not? No. No, not theta is to 1. It is wrong, Lakshmi Gayatri. Charmi Priya, are you listening? For 360 degrees, full circle, the length on the circumference is 2 pi r, Nana. Okay. This is for full circle. But look at here, if I move from A to B, this is a part of circle, just like arc, part of circle. Part of circle makes an angle theta here at the center. So not for 360 degrees, if it makes an angle theta, what is here? That length on the circumference. Okay. The length on the circumference for 360 degrees, I know 2 pi r. For theta angle, how much I am going to calculate here? For theta angle, cross multiplication method, theta into 2 pi r by 360. Okay. Then here, this is 360 degrees is nothing but 2 pi radians, Nana. So here 2 pi cancel. You are getting this is equals to r theta. This is the length of AB. Okay. That is in mathematics called as length of arc. Length of arc is equals to r theta. This is a formula from mathematics. All of you understood, Nana? Length of arc. Try to remember. Why? Because in our physics, many times we use this formula, length of arc. Okay, second time I won't explain. Straight away I will take this formula. Right? Keep in mind. So I'm here erasing this explanation. So try to remember that formula. L is equals to R theta. Okay. Yeah. Now you remember, Nana. Why? Because you have to remember. Many times we use. Okay. Length of arc is nothing but length between 2 points is the distance. So distance I am getting here R theta. Okay. Divided by displacement, the length of the straight line, Nana. This straight line in the triangle, observe here. This is the radius, or means what is this? Is OB. OB is also radius or not? Yeah. You can write. Yeah. So it is also radius, means it is isosceles triangle, Nana. Okay. In this isosceles triangle, if you drop one angular bisector, exactly that meets at the center. Okay, and the angle here becomes, since it is angular bisector, theta by 2. Okay, exactly meets at center means this length of straight line will be AB by 2. Am I right? Yes, I am going to use sine theta here. Now you are coming to the point perfectly. So in this triangle, right angled triangle, sine theta by 2, I am going to write here. Sine theta by 2 is the opposite side. Opposite side is AB by 2 by hypotenuse. Hypotenuse is R. Okay. So here R sine theta by 2 cross multiplication, Nana, is equals to AB by 2. So once again cross multiplication. 2R sine theta by 2 is equals to AB. Okay. So AB is the displacement. Yeah, I am going to substitute here. That only I told you, Manikanta, arc length of arc is the distance. Path length is the distance, na. It moved on the circumference of the circle. So path length is AB. What do you say, Manikanta? Right. So distance is r theta by, good. AB is 2r sine theta by 2. Now you will get the answer. Yes. So here r cancel. The answer will be theta by 2 by sine theta by 2. So is it clear? Is it clear, Nana? Yeah, good. So I clarified your doubt, Nana, what you asked. I think you are Tanisha. Am I right? Yes, sir. Okay, good. But who asked, that person is not responding. Tanisha. Yeah, good. Right. Here, that's what I explained. Distance, displacement, this part completed, Nana, previously. Okay. Next, what we covered in this chapter, what is speed, what is velocity. This part also completed. Completed parts we are writing here, Nana. This part completed. Okay, this part is also completed. Right? And next, third one here. What we completed, uniform speed and uniform velocity. Okay, Nana. Never mention like. Okay. Next, acceleration. Uniform speed and uniform velocity. Okay. This part is also completed here. Okay. Then we entered into, I think, acceleration part. Okay. In that acceleration, uniform acceleration completed. Okay, this part we solved many questions. Okay, more than enough, I think. Uniform acceleration, many questions we solved. And then now we are coming to the concept of here deceleration. Okay, we are coming to entering into the concept of uniform deceleration after completing these many concepts. Non-uniform later I will explain. Okay, we require a lot of mathematics related to non-uniform. Okay, we give some time and then we discuss. Okay, uniform deceleration. Sorry. Okay, deceleration or retardation. Uniform retardation. Both are same now. Yeah. Uniform retardation. Good. Yeah, we are going with the uniform deceleration. This concept. Okay. Uniform deceleration means anyone here knows the concept, you know, what is meant by that is negative and yeah, you're right. Acceleration is positive and deceleration is negative. And one more, velocity will be increased or decreased in case of deceleration. Yes, yes. Not increase, decrease. Okay, increased is acceleration. Okay, decreased is deceleration. So here I think, yeah. Majority of the students know this concept. Okay, if the velocity is decreased, okay, decreased uniformly, then we say the body is said to be moving with uniform deceleration. Okay, this is uniform deceleration. So first thing what we have to remember, the velocity is decreased in this case. First we have to remember from the definition. And number two, while solving in numericals, we have to remember that the in place of acceleration a, we put minus a. Okay, where minus a stands for deceleration. Okay, so anywhere in problems, Nana, if they mention the body is decelerating, straight away you put in place of a minus a. That's it. Negative sign. That's it. Straight away you can put. Okay, na? And while decelerating, try to remember, surely the velocity is decreasing means at one point its velocity should become 0. Okay, so surely one more point you have to remember, after certain time, its velocity becomes 0. Okay, can I erase this part, Nana? Yes, okay, right. Okay, erasing here that part. But try to remember this formula. Arc length is equals to, next time you have to respond very quickly. Length of arc is equals to r theta. Okay, now? Right. Then come to here. Okay, velocity becomes 0. This you have to remember. Okay, and here while decelerating, the best thing what you have to do, if I use the equation 1, v is equals to u plus at. Okay, here I can put 0, v is equals to 0 to find what? The time taken to come to rest. To come to rest means becoming final velocity 0. Okay, where we use this equation, Nana. And number 2, here we use the equation s is equals to ut plus half at square. Okay, sure madam, sure, it's 4 only. Can I extend 1 more minute with your kind permission, Ishan garu? Ishan is not giving permission. Deepali okay, Aditya okay, Kirti okay, Affan okay. Okay, what about Ishan? Ishan, did you respond here? Okay, right, no problem. S is equals to ut plus half at square, right? It's a 4-1 on Nana. So, Papam, I think you have a lot of work there. So I can stop here. I will continue tomorrow, Nana. No problem. Okay. Bye, everyone, Nana. We'll continue tomorrow. Right? No. Okay. I will rewind the pages. Then you can take here the screenshots. This is first page, Nana. Is it over? First page? Oh, thank you. Second page? Okay. No, then right. Then it's okay. Right. We will continue this deceleration in the next class. No problem, no problem. Nothing to say. Sorry. Okay, na? Bye, Mari. Sure, I will send. Okay, bye, Nana.